This lesson is on adding and subtracting square roots and radical numbers. In order to add and subtract radicals, you require like terms. Think for a moment about what like terms are. Problems like 3x plus 5x are like terms because they both have the exact same letter. 3x squared plus 5x are not like terms, they cannot be combined. So what we're looking for instead of so much like terms is the idea of like radicals. They need to have like radicals or like terms in order to be combined. So looking at the first example, square root of 2 plus the square root of 2. Do they have like radicals? Yep, they're exactly the same. Square root of 3 plus the square root of 2? No, they're not like radicals. This next one, negative 4 square root 7 plus 3 square root 7. Notice that it's not necessarily the number in front, just like if this were the problem, you'd be looking at the x's. So we're looking that the radical themselves are the same. Yep, they're the same, so we can go ahead and add those. Let's see. Nope. One has a square root 7, one has a square root 2. Before you judge a book by its cover, because I understand that that's a square root of 9 and that the other is a square root of 4, but what is the square root of 9? Well, it's 3. This problem is really 2 times 3, which is 6, plus 3 times the square root of 4 is 2. That's also 6. So can these be combined? They sure can. 6 and 6 is 12. So there really weren't any radicals to have to add together anyway. And then lastly, the square root of 12 plus the square root of 27. Before you go ahead and say no, they don't have the same radical, you've got to consider, could the radical be broken down? Well, 12 breaks down to 4 and 3, 2 and 2, so it's 2 square root 3. 27 is 9 and 3, 3 and 3, so it's 3 square root 3. So even though the original problem didn't seem to have like radicals, once you reduced and everything is in its simplest form, it does indeed, or can indeed, be added. All right, moving on. When we simplify, combining like radicals is just like combining like terms. And I have an example right here. It says 2x plus 5x equals 7x. So now when we go to add, a like term is a like radical. So for instance, if it were 2 square root, I don't know, I'm making up a number, and 5 square root the same thing, I'd have 7 square root 3. So just like the x that was carried through to say 2 apples plus 5 apples is 7 apples, same thing here. The square root's coming through. So problem A. There's really ones in front. 1 square root 2 plus 1 square root 2 is 2 square root 2. We are simply combining like terms. Letter B. Mentioned in the previous slide, these aren't like terms, so they can't be combined. When you talk about simplest form and simplify, well, it is as simple as it could go, just like, maybe not the best example, just like something like this is as simple as it can go because they can't be smushed together. A negative 4 of something plus 3 of the exact same somethings, square root of 7, is negative 1, square root 7, or better yet, negative square root 7. Letter D, square root 7 and a square root 2 can't be combined. So it is in simplest form. Letter E, did this one on the previous slide, but in case you didn't catch it, the square root of 9 reduces to 3, plus the square root of the square root of 4 reduces to 2, so the answer here is 12. And lastly, for letter F, slightly different than the one on the other slide, 12 reduces to square root 12, 4 and 3, 2 and 2, 2 square root 3. Square root of 27, 3 square root 3 minus square root 3. 2 plus 3 is 5. 5 minus 1 is 4. And that's it. That should take care of it. The only thing that would make this slightly harder would be, let me take this example and let me make it a teeny bit harder, just so you can see one more option. Let me add a page. All right, so if we were to take that square root 12, I'm just making an example of. Well, I said the square root of 12 was 2 square root 3. The only thing that would make it harder would be having that original number out in front. Square root of 27 is 3 square root 3. So again, to make it harder, I could possibly put a number out in front, but you're still just combining like terms. So you're breaking down the numbers like you always have, and you're adding them or maybe subtracting them. Please let me know if you have any questions. Thank you very much.